Have you ever stopped to wonder, is the sun getting hotter? It's a question that's been sparking debate and scientific investigation. The sun, our closest star, is an entity of immense energy and power. It's a constant presence in our lives, bathing our planet in light and warmth. Its heat is the engine that powers life on Earth, driving our weather, fueling photosynthesis, and making our blue planet a habitable oasis in the vastness of space. But could this life-giving furnace be heating up? Scientists have been scrutinizing the sun's behavior, seeking clues in its fiery heart and its outermost coronal reaches. They're sifting through data, analyzing patterns, and wrestling with the implications of a potentially warming sun. The stakes are high, for even slight shifts in solar output can ripple through Earth's climate system with far-reaching consequences. Join us as we delve into the mysteries of our closest star and explore the evidence for its potential warming. The sun's core is a nuclear furnace, where hydrogen atoms fuse into helium, releasing enormous energy. This energy, also known as nuclear fusion, is the powerhouse of the sun. It's like the engine of a car, constantly running, constantly generating energy that fuels every solar activity and lights up our days. The sun's structure is fascinatingly complex, with each layer playing a crucial role in the transfer of this heat. Picture a layered cake, each layer having its distinct flavor, yet contributing to the overall taste. Similarly, the sun's layers, each with its unique characteristics, contribute to the sun's overall temperature and activity. The sun's surface, known as the photosphere, is where we see its visible light and feel its warmth. This is where the sun's heat is most evident to us, with temperatures reaching about 5,500 degrees Celsius. It's like the stovetop, where the heat becomes tangible. Above the photosphere lies the corona, an outer layer of the sun that is mysteriously hotter than the surface, with temperatures exceeding 1,000,000 degrees Celsius. It's like the flame of the stove, not directly in contact, yet hotter than the surface. But the sun's heat isn't constant. It ebbs and flows in a rhythm known as the solar cycle. Picture the changing seasons, from the warmth of summer to the chill of winter and back again. The sun also goes through its cycles, with periods of increased and decreased activity lasting roughly 11 years. These solar cycles influence not just the sun's temperature, but also Earth's climate. Just as Earth's seasons can bring changes in weather, the sun's cycles can also lead to solar weather variations. From the spectacular display of auroras to disruptions in satellite communications, these solar cycles have a tangible impact on our planet. Solar cycles, periods of increased and decreased activity lasting roughly 11 years, influence Earth's climate. So is the sun getting hotter? That's a question scientists are still trying to answer. But one thing is certain: understanding our sun is key to understanding our place in the cosmos. Recent satellite measurements have detected slight increases in the sun's total irradiance, the amount of energy it emits. This has led some to suggest that our star is warming up. But before we jump to conclusions, let's unpack this a little bit. Firstly, the sun, as you know, is not a static body. It undergoes various cycles of activity, and its output can fluctuate over time. Detecting an increase in irradiance might seem alarming, but it could simply be an upswing in the sun's natural rhythm. The challenge lies in accurately measuring the sun's temperature. You see, the sun's corona, that superheated region above the photosphere, reaches temperatures exceeding 1,000,000 degrees Celsius. And yet the photosphere, the sun's surface, is much cooler, averaging around 5,500 degrees Celsius. So when we talk about the sun's temperature, we need to be clear about which part we're referring to. Furthermore, the sun's heat and light don't reach us directly. They have to pass through space and our atmosphere, both of which can affect how much energy we receive. So even if the sun were getting hotter, it doesn't necessarily mean we'd feel the effects on Earth. And then there's the issue of long-term data. To truly understand if the sun is warming, we'd need to observe it for a period much longer than our current technological capabilities have allowed. It's not enough to look at a few decades of data. We'd need to look at centuries, if not millennia. Finally, we come to the debate around the sun's role in climate change. While it's true that the sun's output can influence our climate, it's just one piece of a very complex puzzle. Human activities such as burning fossil fuels and deforestation also play a significant role in climate change. So, is the sun getting hotter? The answer, as with many things in science, is not straightforward. Understanding our sun's warming trend is a complex task that requires long-term data and careful analysis. If the sun is indeed warming, what are the potential consequences for our planet's climate? This is a question that scientists around the globe are working tirelessly to answer. As we delve deeper into the potential implications of a warming sun, we're entering a realm of possibilities that could dramatically reshape our world. The first potential consequence that comes to mind is an increase in extreme weather events. With more solar energy bombarding our planet, we could see more intense heat waves scorching our lands. This could lead to prolonged periods of drought, threatening our water supplies and agricultural productivity. The delicate balance of ecosystems could be disrupted, with devastating effects on biodiversity. But the repercussions don't stop there. Higher temperatures mean more melting ice. As glaciers retreat and polar ice caps dwindle, sea levels could rise significantly. This is a grave concern for coastal communities worldwide. Imagine cities like Miami, New York, or Venice being gradually swallowed by the encroaching sea. Millions of people could be displaced, creating a global refugee crisis of unprecedented scale. These scenarios might sound alarming, but they underscore the urgent need for continued research and predictive modeling. Understanding the sun's influence on our climate is a complex task with many variables to consider. It's like piecing together a cosmic puzzle, where each piece helps us see the bigger picture with greater clarity. Efforts are underway to collect more long-term data, refine our models, and gain a better grasp of the sun's behavior. Satellite missions are monitoring solar activity, while ground-based observatories keep a watchful eye on our star. Scientists are also studying past climate records, looking for clues about the sun's impact on historical warming and cooling periods. But this isn't a challenge that one country, or even a handful of nations, can tackle alone. It's a global issue that demands international cooperation. We need to pool our resources, share our knowledge, and work collaboratively to understand and mitigate the potential impacts of a warming sun. So, while the sun continues its celestial dance, we on Earth have work to do. Our future and the future of generations to come may very well depend on it. Addressing the global challenges associated with climate change requires international cooperation and scientific collaboration. Our sun isn't the only star in the universe with a fiery temperament. Stars, much like people, go through stages of evolution, changing over their lifetimes. From their fiery birth in nebulae to their often spectacular demise, stars undergo dramatic transformations and their temperatures can vary wildly. Take red dwarfs, for instance. These are the most common type of star in our universe, and they're also the coolest. Not cool as in trendy, but cool as in temperature. Red dwarfs burn at a much lower temperature than our sun, and it's this cooler temperature that gives them their distinctive red hue. On the other end of the spectrum, we have blue giants. These stars are much hotter than our sun, burning at temperatures that can exceed 20 times that of our solar powerhouse. Their high temperatures give them a blue appearance, and they're among the most luminous stars in the universe. But the real hotheads of the universe are the massive stars known as supergiants. These stars can reach temperatures exceeding millions of degrees Celsius. They burn bright and fast, often ending their lives in a spectacular explosion known as a supernova. The universe is a vast and diverse place, with stars of all sizes and temperatures. Understanding them and their fiery temperaments is an ongoing scientific quest. So, is the sun getting hotter? It's a complex question with potential implications for our planet. The evidence suggests a possible warming trend, but the verdict is still out. The sun's temperament and its impact on our climate are subjects of ongoing research. It's crucial for us all to stay informed about climate change, supporting sustainable practices to mitigate its impact. By supporting further research and sustainable practices, we can ensure a brighter future for generations to come.